So we're going to look at a free response question. It says water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of square root t plus 1 gallons per minute. So we have water being pumped in and water being pumped out. So again, rate in, rate out. That's what I am thinking when I see, read, or hear this problem. So then it says from 0 to 120 minutes, 2 hours. At time t equals 0, the tank contains 30 gallons of water. That is an initial condition. So again, fundamental theorem of calculus, you are given an initial condition. And that's something that I continue to reiterate. That is an initial condition. So what that means is that at time 0, there is this 30 that needs to be added back to our problems as we integrate them. That's like the plus c if you took an integral that's indefinite and you have to find the constant. The constant is 30. So part A says, how many gallons of water leak out from 0 to 3? So let's say that we will call the leaky function L, and we're going to call that function square root of t plus 1. So we want to know how many gallons of water have left the tank in the first 3 minutes. So that's like integrating that function from 0 to 3 of L of t dt so that's like integrating 0 to 3 of square root t plus 1 dt. And our reverse power rule would tell us that that's like 1/2. So that gives us the integral of t plus 1. Add an exponent, so it becomes 3/2 multiplied by the reciprocal of the fraction that would go in our denominator, so 2/3. And then we're evaluating from 3 to 0, which is really nice because the 0 part's going to cancel out. So you have 2/3, 3 plus 1 to the 3/2 minus 0. 3 plus 1 is 4. The 2 in the bottom represents a square root, so the square root of 4 is 2. 2 cubed is 8. 8 times 2 is 16. Yes, 16 thirds. And I'm silly because that is not actually 0 because it's just not 0. 0 plus 1 is 1. Square root of 1 is 1. 1 cubed is 1. So this is actually minus 2/3. Sorry, the way I wrote it out before, my value had to be multiplied in. So you get 16/3 minus 2/3, which is 14/3. So that 14/3 represents the amount of water that is being leaked out of the tank 0 to 3. So that 14/3 represents, in terms of a sentence, the gallons of water leaked out during the first 3 minutes. 14 thirds is the amount of gallons leaked out. 14 thirds is the number of gallons leaked out during the first 3 minutes. Part B, how many gallons of water are in the tank at 3 minutes? This is different than the amount of gallons that have leaked out. So, how many gallons of water are in the tank at 3 minutes? Well, now I need to take into account the initial number of gallons, the number of gallons being pumped in. So we'll say that pumped in is P of T, and in this case P of T is 8. And then remember L of T is leaked out, which is square root of T plus 1. So the number of gallons in the tank at 3 minutes, so we'll say the amount of gallons in the tank is A of T. And we'll say that that's kind of like the initial plus the amount pumped in minus the amount pumped out. And we already know this amount. We just calculated it. So it's like 30. The integral of a constant is a rectangle, so that's like a rectangle of base 3, height 8. So we're adding 8 times 3 minus what's being pumped away. So 8 times 3 is 24. 24 and 30 is 54. 54 minus 14 thirds is actually how you're allowed to leave your answer on the AP exam. So the amount of water or gallons left in the tank would be 54 minus 14 thirds gallons. Or if you're like me and you really don't like it looking like that, you could take 54 times 3 and then get a common denominator, subtract 14, and you get 148 thirds. Part C, write an expression for A of T, the total number of gallons in the tank at time T. So we kind of pretty much just did that. That is this right here. We just need to make it more generic. So we're going to say that A of T is equal to the initial plus the amount pumped in minus the amount pumped away And again, you could write in our P of T and D of T if we define them above, or you could just say 30 plus, and you could do one big integral, 8 minus the square root of T plus 1. So again, there are many, many ways to kind of write some of our answers. Like here's just 2 examples. So make sure you keep that in mind as you're working through your problems. So it says write an expression for A of T, and then part D. At what time T is the water in the tank a max? So we always get these max questions. We've seen it repeated over and over and over again. So the time that the water will be at a max is when the derivative of the amount of water is equal to 0. So when will the derivative equal 0? So you have to take the derivative of the function that you were just given. So the derivative of a constant will 0 out. So then A prime of t is really equal to P of t minus L of t. which is simply like saying 0 equals 8 minus the square root of t plus 1. So then you have the square root of t plus 1 equals 8. So we're going to square both sides. T plus 1 equals 64. Subtract 1 away. And we see that at time 63, or at 63 minutes, the amount of water in the tank will be at a potential maximum. So that's our critical point. And what we would need to do is compare A of 0, which we should know is 30. That was given. A of 63 and 120. So A of 63 would come from plugging it in up here. So that would be like 30 plus the integral from 0 to 63 of 8 minus square root t plus 1 dt. So 8 becomes 63 times 8 minus, we already said the antiderivative of that square root way up here. It'll be 2t plus 1 over 3 to the 3 halves. And to be honest, this would probably be a calculator question once it got to this point. So, not to waste your time, we'll just do it on a calculator. So I'd do 30 plus math 9, 8 minus second square root x plus 1. So we get 193.3 repeating. I'm running out of room. And then you'd also go and hit that and do it again and change your bound to 120. And you get 103.3 repeating. And we can see, in fact, that A of 63 will represent the absolute max amount of water that could be in the tank. So it says at what time is the water in the tank a maximum? That answer would be at A of 63, and our justification is coming from all this information. So what I want for you to do is to finish out those remaining problems. So you're going to do number 12. And I will say for number 12, just like a couple of hints, tricks, like things to take into consideration. Make sure you understand that like the derivative of the integral for this part, so it says find g prime of 5. Well, if that's g, then you take its derivative, and this is also 100% a calculator question. So please make sure on number 12 you use a calculator. And make sure you put your g function into your y1. And honestly, once you do that, everything is really similar to what we've been doing. This 500 is really important. So tomorrow when you come in, we're going to kind of almost grade this as if it was an AP. I'm not going to grade your paper personally. You're going to grade your own. And then I want you also doing questions 5 through 12, essentially, because we did number 4. So you'll pick up with 5. 5's a lot like 4. Just tell me, what does that mean? Interpret it. So a lot of these are interpreting. Just interpret, interpret, interpret. What does this mean? What does it mean? You're actually not doing some math in some of these. You're telling me, what does it mean? So you're doing this, and then you are going to the packet we had from the other day. It had on the front of it the graph with the fundamental theorem on it. So you're doing those rate in and rate out problems as well. So that's why yesterday I kind of gave you these as an assignment and said, hey, you can work on these, just don't do the problems that I'm going to do in class with you. So you're working on the rest of this packet as well. Here we go. So we already did the front page. We already went over all of that. You're going to pick up in here, and if it has the calculator symbol next to it, use your calculator. This one, I actually just did that problem very, very similar to this. Entering, exiting, initial condition. So again, you're just telling me, what does this mean? What does it mean? Initial, enter, exit. Multiple choice. So go through that, do those packets. I'm going to stay on the Zoom if you get stuck, if you already started some of these problems and you don't know what to do. That's what the next like 35 minutes of class time is for. If you guys want me to put you into breakout rooms and you can work together, just say, hey, Mrs. McBride, can you put blank and blank with me in a breakout room? And I will gladly do that as well.